What's up, guys? It's Mr. Brengle, and today we are going to be going over the concept builder, keeping track of momentum, hit and stick collisions. Hit and stick collisions. So that's another way of saying perfectly inelastic. Okay, remember, perfectly inelastic collisions are the ones where the objects collide and then stick together and move as one object. Okay, so let's take a look at this. You're going to do all three trophies, Apprentice, Master, and Wizard. They build on each other, and it's really good practice, which is why we're doing it. It's a little bit longer this time. There's two types of questions. One like this, where they give you a chart that's been filled out and have you answer identify a statement that explains this up here. And sometimes they'll actually have you fill out the chart when it gives you information about the collision. Okay, so I'll do an example of each one of those for each level here, or each trophy. Okay, so in this first situation, it shows us a chart with data for before the collision, after the collision, and the momentum change. These numbers are referring to the momentum of the red cart and the blue cart. It doesn't specifically have units up here or anything, but we can just call it 150 units of momentum, whatever units they're using, usually kilograms times centimeter per second for these concept builders. So this is saying that the red cart has 150 units of momentum before the collision, and that it has 100 after the collision. That the blue cart has 0 before the collision, meaning that it's probably not moving, and it has 50 after. And then it shows us for the system that the total momentum of the system is always 150 before and after. And then it shows us the momentum change for each car. Okay, so let's read the statements. The momentum of the red cart is equal and opposite to the momentum of the blue cart. A lot of people will be tempted to pick this because it says equal and opposite, but it is specifically talking about the momentum, meaning either before or after, not the momentum change. So let's move on. The momentum of the red cart is equal to the momentum of the blue cart. No, not equal. You can see that here at any time these are not equal. The momentum of the red cart and the blue cart does not change. Again, that is incorrect because we see that it goes from 150 to 100 for red and 0 to 50 for blue. Last one, the momentum lost by the red cart is equal to the momentum gained by the blue cart. Absolutely, yeah. So the red cart lost 50 units of momentum. The blue cart picked up 50 units of momentum. So we'll choose that answer. Okay, it's giving me another one of these, so I'll try to get through this quickly. But this one is basically showing us that the system's momentum before and after the collision is equal. So we'll need to find that answer, and that would be the fourth one down. It says the system momentum before the collision equals the system momentum after the collision. And that is true, and that's what's been highlighted right here, so we will choose that answer. Okay, so now looking at the math. So basically, this has to always hold true, right? The initial momentum of the system must be equal to the final momentum of the system, okay? So that means that the momentum initially for A plus the momentum initially for B must be equal to the final momentum of A plus the final momentum of B. Okay, and then you can obviously remember each one of these would be, this would be the mass of A times A's initial velocity. Right here, plus the mass of B times B's initial velocity, right? And then the same thing on the final side. So let's kind of keep that in mind as we go through this. It says a red cart moving rightward with a momentum of 40 kilograms times centimeter per second when it collides with a blue cart that's initially at rest. Okay, so that has given us the parameters of the collision before it happens. So the red cart, we're going to enter the momentum here, is 40 kilograms times centimeter per second of momentum, and the blue cart's not moving, so it has no momentum. Okay, now to get the system momentum, you just need to add these two together, the red and the blue. So the system momentum is 40 plus 0, which is just 40. Okay, now because of this right here, we know that the initial momentum is 40, and therefore the final momentum of the system must also be 40. So we're going to plug that in. Okay. Now we're going to figure out how this works for after the collision. it tells us next that the red cart has 3 times the mass of the blue cart. Okay? So, I know that on the initial side of the equation, it's 40, right? The momentum of A is 40. So 40 is equal to, basically, they move together now. So another way to write this would be the mass of A times A's final velocity plus the mass of B times B's final velocity. Okay? Or you could write it like this. 40 is equal to the mass of A plus the mass of B times their final velocity. Okay? So, since all I know is that the red cart has 3 times the mass. So, I'm just going to put in 3 for the mass of cart A, which is the red cart, and cart B, I'm going to put in a mass of 1. Okay, so I'll do it on both sides of this equation here. I'll show you how it works. So 40, what we're going to do is we're going to solve for the velocity and use that to then plug back into the equation and solve for the momentum change. So the red cart A, has 3 times the mass, so I'm going to plug in a 3 for mass, okay, times its final velocity, okay, plus 1 for the mass of B times B's final velocity, okay? Now, here's the thing. These 2 carts are moving together now, right? The 2 carts stick together and move with the same speed after the collision. So I can actually add these together because I know that the final velocity is the same for each. And the equation just becomes 40 is equal to 4 times the final velocity. Okay, well, if I divide 40 by 4, I can clearly see that the velocity here is 10 meters per second. Okay, in fact, centimeters per second. Okay, now, if we did it with the other version of the equation, it's going to be the same thing. We're going to get 40 is equal to 3 plus 1 times the final velocity. So again, it comes out to be 40 is equal to 4 times the final velocity. And that's going to give us 10 meters or centimeters per second. Okay, so the point of this now is that we now want to go in and say, okay, well, since object A had 3 times the mass, it's going to have 3 times the momentum now. So 3 times 10 centimeters per second. Okay, and so we'll go ahead and plug that in. This is going to be 30 here, and then blue cart is going to be 1 times the velocity, which is just going to be 10. And you can see that those now add up to 40, which is what our total has to be. So the red cart actually lost 10 units of momentum, and the blue cart picked up 10 units of momentum. Therefore, the momentum change is 0 because they were balanced out, right? So the total momentum of the system before and after is equal. There's no momentum change for the system. But the red cart and the blue cart do change momentums, but it's balanced out. Okay, so that's kind of how you're going to attack these math problems. Let's actually go on to the next trophy here. So we'll check the answer here, and even though we're not completely finished with this trophy, we are just going to go ahead and move on. We're going to go to the main menu, and we are going to move on to the master level. Okay. So it's another one of these questions here. It's showing us the momentum change of the red and the blue cart. They are equal and opposite. Let's find that answer. It says that the last one down here says that the momentum lost by the red cart is equal to the momentum gained by the blue. So that is correct. We will choose that answer and move on. Okay, so now this time you can see the difference up here is that it has actually just given us the mass of the red cart, the speed of the red cart, and then it's also giving us the mass of the blue cart that's initially at rest right there, okay? And then it tells us that after the collision they stick together and move to the right with a speed of 30 centimeters per second, okay? So let's take a look here at what we've got. We actually have to calculate this. So we're going to do, this is going to be the mass of A times A's initial velocity plus the momentum of object B, which since it's initially at rest, I'm going to go ahead and plug in 0 here. And then that has to be equal to the mass of A plus the mass of B times their joint velocity at the end, okay? And we can go ahead and solve for the initial momentum of A. Let's go ahead and do that. We're going to do 0.5 kilograms times a speed of 90 centimeters per second. I'm just going to plug in 90 here. Okay, and then that's equal to 0.5 kilograms plus 1 kilogram for the mass of B, or the blue car, times the final velocity, which is 30 centimeters per second. Okay, so I got a step ahead of myself here. We're actually going to change this up just a little bit, but we can go ahead and fill in a couple things here. So the momentum of object A initially is obviously, 0.5 times 90 is just 90 divided by 2. So that's going to be a total of 45 units of momentum for the red cart initially. We can plug that in. So we'll put 45 right here. We know the blue cart's not moving, it's 0. That means the total system momentum initially is 45. And because of that, we know that the final momentum of the system must also be 45, and that the momentum individually of the red and the blue cart must add up to that. Okay, so because of that, what we actually want to do here is we want to separate these masses. So I'm actually going to rewrite this as 0.5 times 30 plus 1 times 30. Okay, so I've just basically split these up right here and multiplied them each by 30 centimeters per second. And the reason for that is I actually want a number for each, for each one. So this one's going to come out to be 15 plus 30. Notice that that is equal to 45. Okay, so I can now go in and plug in 15 units of momentum for the red cart and 30 for the blue cart. Okay, so basically the red cart slowed down and the blue cart sped up, right, when they hit and moved together. So they're both moving at the same speed because they're connected. It's just we can separate the momentum individually of the carts because they have different masses. So 30 units of the momentum are made up by the blue cart and 15 by the red cart after the collision. Okay, so obviously there's a negative 30 unit of momentum change for the red cart, and there's going to be a positive 30 for the blue cart, meaning that the total momentum change is 0. Okay, great. So obviously that one's just a little bit different because you're given the numbers initially. So since we've done that one, let's now go look at the wizard level. Okay. And the wizard level is again just a little bit different here. Okay, so 1 kilogram red cart is moving right with the speed of 50 centimeters per second. So 1 kilogram cart, 50 centimeters per second to the right, collides with a blue cart that's 0.5 kilograms and is also moving rightward with a speed of 20 centimeters per second. Then it says after the collision they stick together, move to the right with a speed of 40 centimeters per second. Okay, so we're going to need to go through and do the same types of things that we did before. We're going to want to go ahead and make our equation, and this time the blue cart is moving to start with. So we're going to need the mass of A times A's initial velocity plus the mass of B times B's initial velocity. And then that's going to be set equal to, we'll write it this way this time, the mass of A times A's final velocity times the mass of B times B's final velocity. Okay, just remember that combining the masses, like doing mass A plus mass B times the final velocity, same thing, okay? All right, so we can go ahead and plug in numbers here. So 1 kilogram mass for the red cart, so 1 times 50 plus for the blue cart it's going to be 0.5 times 20. Now we do need to be careful. It says that in this case, both of them are moving rightward, so we don't need to worry about negative numbers there. You can leave it the way that it is. Okay. So let's kind of pause there and just look at the initial side of the collision. So we know that this object A is going to have 50 units of momentum plus object B, which is going to be 10 units of momentum on the initial side. So we can actually plug that in now. So I can plug in 50 for the red cart, and I can plug in 10 for the blue. Now, we haven't had one where blue has an initial momentum, so make sure you add these two together. It gives you an initial system momentum of 60. Now we can figure out after the collision. We do know that the total has to be 60 though. Okay, so again, the mass of A here is 1 times 40 is the final speed of the cart system there, the two carts together. And then this one is going to be 0.5 times 40. Okay, and I actually wrote those, all of this was supposed to be up here, but this is just going to be 40 plus 20, and you can see that is equal to 60, so that gives us the 40 is the momentum of the red cart, and the momentum of the blue cart is 20. Okay, so they add up to 60, it works out for us. Okay, now for the momentum change, it's negative 10 for the red cart, it's positive 10 for the blue cart, and the total is 0. Okay, so really the same process, it just kind of changes your equation depending on what, whether they give you the initial momentum to begin with, or if you have to calculate it, if the blue cart is not moving versus moving, so those things obviously change. Okay, so you are going to complete all 3 trophies, and I recognize that this one is a little bit harder. It's going to take a little bit longer, but it's worth it because I will know that you really understand the math and the concepts behind the perfectly inelastic collisions. Let me know if you have any questions.